Getting into our discussions of biomacromolecules, first thing we have to talk about is lipids. And there's lots of different ways we can classify lipids, but some notes that you want to make generally speaking about all of them is that they are non-polymeric. They don't form polymers. In case this wasn't already obvious to you, they are insoluble in water and soluble in organic solvents. And therefore, if they're insoluble in water and a polar solvent, they tend to be nonpolar, or we call them hydrophobic. And in the next series of videos, we'll be talking about all of the different classes of lipids. First on our list, we have the free fatty acids. These are really simple structurally speaking. They're really just a hydrocarbon chain attached to a carboxylic acid. The carbon, and then a carboxylic acid, and you now have yourself a free fatty acid. And the two things that we use these for is they're used as fuel for burning up energy, and they're also used in the structure of membranes. Next on our list are the triacylglycerols, which, as their name implies, tri meaning three, and then glycerol. This is predominantly used in the storage mechanisms. We're storing ATP, well, storing energy that we can use to make ATP in the context of glycerides, of just that, of glycerol, which sounds like it's commonly used term there, but we have glycerol alcohol acting as a backbone, and then attached to that glycerol alcohol are three fatty acid tail groups. So I'm just going to say FA for that. And they're all connected with an acyl group. That's the linking part to it. Next we have the phospholipids. Phospholipids, I spelt that badly. I'm sorry. But anyways, these things just are amphipathic. They're the amphipathic molecules of the membrane. Next thing we have are the glycolipids, which, as its name implies, gly, sugar, lipid, fat, right? So these are part sugar, and then they are part lipid, part fat. These are really useful for signaling at the extracellular membrane or as a component of the cortex, but usually on the extracellular parts. I'm just going to say ECM for signaling. And then last, but certainly not least, we have, hopefully if I can fit this on here, steroids. Steroids have a polycyclic structure. They have many rings to them, and that's what makes them pretty unique. And then they have two, I guess, functions would be to serve as, so I'm just going to say functions, as hormones and as a constituent of the cell membrane. All right, so that's what these next series of videos are going to be talking about, each and every one of these individually.